Okay, we now moving into 10.2, and that is the arc measures. Okay, find the arc measures. What is an arc measure? Look at the circle with me right here. And the first thing I'd like for you to capture, and that is the vocabulary again, and that is central angle. Okay, what is a central angle of a circle? A central angle of a circle is an angle whose vertex is the center of the circle. That's by definition. Okay, I repeat, a central angle of a circle is an angle whose vertex is the center of the circle. Means right here, if I have the 2 points A and B on the circle, and I simply connect CA and CB, okay? Then they will make an angle. The angle whose vertex is at the center of the circle, this angle is called, the angle right here, the central circle angle is called ACB, okay? That is the angle ACB is called the central angle, okay, whose vertex C is the center of the circle. All right, if that is the case, you see the center angle will now have another significant vocabulary, and that is, what if the arc AB, it is intercepted by the central angle, the arc AB right here, okay? The arc AB right now, it is called the minor arc, okay? Minor arc. Okay, here you go. Minor arc. Why call it minor? Because it is less than 180. So by definition, a minor arc is an arc that has a less than 180 degree. So arc AB. You see that minor arc by definition is less than 180 degree, and this is the notation like a curve above A and B. Only 2 letters is applied for minor arc. Or you can say, Mr. Chang, what about BA? Same thing too, AB or BA. All right, now you ask Mr. Chang, what if you go counterclockwise, or the other way around? What about AB going like this, Mr. Chang? What do you call that? Let me use different color for you. What would you call if I go another way and I can still define as an arc AB? There we go. If you go for an arc that is bigger than 180 degree, there we go. You see that? If you have an arc that is bigger than 180, you can see you no longer call that minor arc, but you call it what? Major arc, correct. And to differentiate from the minor arc, the notation for the major arc requires 3 letters. Let's call another point on the circle, and that point is D. So the minor arc, instead of go the other clockwise right now, you will have 3 letters, which is A, D, B. There we go. That's it. That is to differentiate from the minor arc to the major arc. So by definition, again, I repeat, minor arc is the arc that is less than 180 degree. And this is the notation by 2 letters and a curve, like a rainbow above that. This one right here, same thing. If you want to say B, D, A, same thing. There we go. But you go by the order like that. And this is the hint for you that if you express an arc by 3 letters, that is a major arc. All right. There is another concept that you will see. That is a semicircle. A semicircle, what is that? A semicircle is an arc with endpoints that are at the endpoints of a diameter. Okay, you guys know that semicircle, which is half of a circle. And with the geometric definition of a semicircle is this, that a semicircle is an arc with endpoints that are the endpoints of the diameter. So there we go. Let's call this is E. Semicircle, EB. Semicircle, half of the circle is 180 degree. So you see the all three related to one another. Semicircle, okay, which is 180 degree. Minor arc is less than 180. Major arc is bigger than 180. That is their relationship right there. Okay, guys. One thing that you can see. Suppose you say, Mr. Dang, what if angle C, and I'm using the degree right here, and I measure the degree. There we go. This is about 65, Mr. Dan. 65 degree. Then if the central angle is 65 degree, can you tell me, guys, what is the measure of the minor arc AB? The central angle has the same degree as its intercepted arc, which is AB is also 65 degree. And that makes perfect sense, right? Because angle C, how about this is angle 1? How about angle C2? You see? EB on the upper part, it's a semicircle. So the whole thing EB, it is 180. If one part of that, which is angle C, takes away 65, what is the other guy? That's right, it is 115 degree. There we go. So you see that the central angle has the same measurement as its intercepted arc. Only happen for central angle. I emphasize central angle with the vertex is at the center of the circle has the same degree as its intercepted arc right there. Okay, so just a little heads up for you guys. Now I am moving into the example, and you will see in example 1. What if I have right now as the another circle, and the diameter runs through like that in example 1, and over here you have circle with the center P, and over here is S right there. Okay, and they gave us the specific value. This is the central angle 110, and they ask us, okay, what is RS? What is the measure? Let's see. They gave you all like that, and they ask find the measure of each arc RS. Where's RS? This is T. Okay, let me take this all the way for you. T, and this is what? This is T, this is S, and this is R. There we go. All right, let me erase this too. Okay, example 1. They ask what is the measure of RS? Well, you can tell the measure of RS is 110 because the central angle is 110 and RS is the intercepted arc of the central angle on the center P. Okay, all right. And the next one, what is RST? R, okay, ST. There we go, RST. Okay, so you now have R. Sorry, yeah, I'm moving one word. Let's keep that. RST. RST. Since you see the both ends of that chord is on the circle, and this is TR is the diameter. Diameter, it cuts the line. Diameter, it cuts the circle into equal half. Therefore, RST is 180. You can tell right away, right? What about the other arc? RTS. RTS. There we go. RTS. RTS. Okay, so you know already that this is half of what? Half of the circle. So the arc right here is 180. And you have another half, which is 180. Take away 110. What is left over here? Let me use another color for you. To find the RTS, you need to know what is TS. Since you have the whole thing over here from R to T is 180. And this one take away 110. So what's left over this for this one? That is 70. So now, just simply, guys, that sets you up for your next example. And that is to find the major arc, RTS. You just simply adding you just simply add the two arcs together, which is RT add TS. 180 add 70. What is that? 180 add 70, and that will give you, 250. And that you conclude example 1. And example 2 is the application, just simply adding the arcs together. Okay, you just add the arcs together, and you guys are very familiar with this, pizza, when you cut and you slice into several pieces, and then you see who has the biggest, crunch. All right, and that is the arc addition postulate, and that's self-explanatory. I'm gonna move into example 3 and help you to capture one significant concept right here, and that is, how do you compare the arc? Sometimes you have the arc at a 90 degree. Let's look at this. This one, okay, has a 90 degree right here. Look at this. There we go. Look at this. Okay, I just make a right angle. So this is a right angle, and that is 90 degree. Suppose if this is a center of a circle and the radius is right here. There we go. So this arc right here, AB, 2 points on that. Suppose this is a circle right here. Got it? So the arc AB, if this is a circle and the center O, you see right here, look, this is very important. Pay attention. The central angle AOB, 90 degree. Therefore, the arc over here is what? The arc over here is also what? That's right, also 90 degree. Now look. If Mr. Dang draw another circle, okay? Draw another circle using the same center. This is what we call concentric circles, and a little bigger radius, okay? How about a C right here, and OC and OD equal each other, okay? This equal to that, and then this one right here, another circle. Yeah, there we go. Same center. Now talk to me, guys. Talk to me. Okay, here we have the arc AB. Is it congruent to the arc CD? That's a very good question. It's also a tricky one as well. Okay, now if you compare the arc AB and the arc CD, and you would say, well, Mr. Dang, the arc CD is also 90 degree. That you are right. But for two arcs to be congruent, they must have two things: the same degree, the arc, the curve, and the length that makes up the arc. Therefore, you see, if the segment, if I make it a straight line, does that congruent to CD, AB congruency? Oh no. Therefore, this is a very good, I would say, geometric concept. For two arcs to be congruent, you must have first the same degree, that is a must. Secondly, the two lengths of the arcs must be the same as well. Therefore, in this case, even though the arc AB and the arc CD both have the degree of 90, but their length that makes them not equal each other. Therefore, you would conclude arc AB is not congruent to arc CD. Okay? All right, I think I made it very clear. For congruent arcs, the degree and the length that makes up that arc must be congruent. There we go. With that saying, we conclude 10.2, and I will post examples for you, homework for you on RenWeb. Okay, guys, have a wonderful day. Bye-bye.